Dear students, in the last class we studied substitution method, chain rule, while we were discussing the differentiation of composite functions. Today we will learn about differentiation of composite functions using a shortcut method. While applying this shortcut method, everything we will do in our mind. So let us see some examples. Example number 1. d by dx of x square plus 1 power 3. If we observe the function properly, we can clearly say that it is a composite function. It is a composition of two functions. One of them is x square plus 1 and the other one is power 3 function. So this power 3 function or the cubic function is operating on x square plus 1, that is the quadratic function. So clearly this is a composite function. Now in substitution method we were putting x square plus 1 as t. Same thing we will do in the shortcut method, but everything we will do in our mind. So I have a piece of paper here. What I will do, my t x square plus 1, I will hide using this piece of paper. So in my mind we have t power 3 and we know that derivative of t power 3 will be 3 t power 2 and our t is x square plus 1. Chain rule says now we have to multiply it by the derivative of t. That is the derivative of x square plus 1. The derivative of x square will be 2x plus derivative of 1 will be 0. This is our answer. Let us see some more examples. More we practice will make us better. d by dx of cosine x power 3 plus 2. Again, this is a composite function. Very clearly, it is a composition of cosine function, cos, and the cubic function, that is x cube plus 2. Cosine is operating on x cube plus 2. So in this case, my t will be x cube plus 2. So using our paper, we will hide x cube plus 2. So in my mind, we have cosine t. Derivative of cosine t will be minus sine t, and our t is x cube plus 2. Chain rule says now we have to multiply it by the derivative of t. The derivative of x cube plus 2 will be, derivative of x cube will be 3x square plus derivative of 2 will be 0. Let us take another example. D by dx of square root of sine x. Definitely, it is a composite function. It is a composition of square root function and sine function. Square root function is operating on sine x. Therefore, in this question, I will put t as sine x. So this sine x let us hide. Now we have in our mind square root of t, and we know that derivative of square root of t is 1 by 2 root t, and our t is sine x. Chain rule says we have to multiply this by the derivative of t, that is sine x. So the derivative of sine x is cosine x. Now let us solve one more example. Example number 4. D by dx of 1 by x square plus x. If we observe the function properly, we can say that this question we can also solve by using quotient rule or the division rule. That is also a correct method to do it. But we will try to solve it using our shortcut method. So if we observe the function, we can say that this is a composite function, and this is a composition of two functions. One of them is x square plus x, that is the quadratic function, and the second function is the 1 by x function. So here we can say that 1 by x function is operating on x square plus x. So let us solve this. In this question, I will put x square plus x as our t. So I have hidden it with my paper. So now the function is 1 by t, and we know that differentiation of 1 by t is minus 1 by t square, and here our t is x square plus x. Chain rule says we have to multiply by the derivative of t. Here our t is x square plus x. So the derivative of x square will be 2x plus the derivative of x will be 1.